And it's my pleasure to introduce our first grand round speaker of the academic year. So Dr. Fleming is there. Hello, Dr. Fleming. So Dr. Fleming, thank you so much for coming to talk to us today, is a professor and former chair of the Department of Biostats here at the University of Washington. He's also worked with the Fred Hutch Cancer Research Center and is a former director of the Statistical Center for HIV/AIDS Prevention Trial Network. He got his BA from the University of St. Thomas and then went on to get his master's and PhD in statistics from the University of Maryland, College Park. He is well poised to talk to us about trial design today because he has had numerous books and publications on the subject. He's authored or co-authored several books and more than 250 research articles peer-reviewed on both the development of trial design, methods for design, conduct, and analysis of trials, and also reporting results of major clinical trials. His work in landmark trials included the senior author position on the New England Journal publication for the prevention of HIV transmission. And this was some work that went on to win Breakthrough Research of the Year by Science Magazine. He's also chaired or served on data monitoring committees for more than 100 clinical trials. He's done extensive work with the FDA for more than 30 years. He's served as a regular member on numerous FDA advisory committees and has voted on the panel for more than 100 occasions there. He's also received numerous awards, including both research and teaching awards. He received the Outstanding Teaching Award from the School of Public Health from the University of Washington, and the FDA Commissioner's Special Citation Award for extraordinary contribution to the agency. He's the 2007 Greenberg Lecturer at the University of North Carolina and has won other distinguished lecturing awards through the years. He is an endowed professor of biostatistical collaboration and was also elected to membership in the NIH, or the Institution of Medicine of National Academies. So again, well poised to talk to us about our discussion today on trial design, specifically non-inferiority trials using active controls. So thank you so much, Dr. Fleming, for coming to talk to us.
Thank you so much. Much to talk about, so I'm going to jump in. It's an honor to be here for Grand Rounds. I look out and I see such a diverse set of experiences and expertise, but there's one thing that brings us all together, and that is if you kind of think back to your undergraduate training and you think of your most exciting class, I'm sure we would all say it was statistics. So I'm delighted to build on that common experience. So we've made considerable progress, obviously, in treatment or prevention of disease. Suppose you have a new intervention that you want to assess, and it's a setting where there's already effective therapies that impact irreversibility and mortality endpoints, prevent HIV infection, prolong survival, reduce MIs. Clearly, you're not going to compare your new therapy to a placebo. It's going to be an active control trial. But it might be a setting where your new therapy isn't necessarily going to deliver better efficacy, but maybe it's going to reduce the toxicity, the inconvenience, the cost of that standard therapy, in which case you may well be interested in non-inferiority trials. And that's the context for what I'm going to be talking about today. So I'll use many examples. One example is the prevention of transmission of HIV. There was this landmark trial that University of Washington scholars were providing significant co-leadership for that showed that if you treat the infected person, you can almost completely eliminate transmission to their partner. That's led to the concept of treatment for prevention. And while that's critical, it's not the whole story, in that we often have some difficulties in identifying when people are infected and channeling them or linking them to care. And so there's also interest in being able to treat the uninfected in what's called pre-exposure prophylaxis. PrEP studies, we've done a number of them. Most frequently, we've looked at tenofovir and emtricitabine, which we call Truvada. And in each of these trials, Truvada was compared against the placebo. And in some of these trials, a University of Washington coordinated partners PrEP trial, a Botswana CDC trial, we had substantial reductions in transmission. But in some other trials in heterosexual women, the numbers of transmissions in Truvada were very similar to placebo. And it seems as though this disparateness in efficacy is tied to the level of adherence of taking these oral Truvada pills. And so as we're moving forward in PrEP, there's interest in alternative strategies. One of those alternative strategies is to use an injectable, Cabotegravir injectable, that would give us presumably enhanced adherence. And by that enhanced adherence, we might expect maybe that Cabotegravir would be somewhat better than the active comparator Truvada. But even if it were similar, it would be of interest because Truvada is part of the backbone of treatment in HIV. And we worry a bit about its use in PrEP as leading to resistance. And so even if Cabotegravir were only similar in efficacy to Truvada, that would be an important advance. And so we have ongoing trials now called the HIV Prevention Trials Network, HPTN 083 and 084 trials, that are specifically randomized comparisons of Cabotegravir head-to-head against Truvada. Now, in those trials, we cannot prove equality. That would take an infinite sample size. And so the issue is, if the goal is to show that or determine whether Cabotegravir is at least similar to or better, in essence, we want to rule out that it's unacceptably worse. And that requires us to define a margin. And that's critical in a non-inferiority trial. What is the threshold for what is unacceptably worse? So I mentioned the comparison of Truvada against Cabotegravir in pneumonia, ventilator-associated pneumonia, where we have piperacillin tazobactam as appropriate and effective standards. We worry about development of resistance. So there was an NI trial of doripenem against piperacillin tazobactam to build our arsenal of antibiotics in the emerging resistance. And in percutaneous coronary intervention, we're looking at antiplatelet strategies like 2B3 inhibitors. They do reduce MIs, but increase bleeds. So there was interest in bivalirudin as an alternative that could presumably or hopefully achieve similar reductions in MI without the same level of bleeds. But it's a serious issue if the standard regimen is replaced by something that's less effective. And so in essence, it's critical that when we're developing or designing these NI trials, that we're rigorous about the margin. So if we're, for example, in our Truvada trial, if we're randomizing and following participants for 2 to 3 years, we have 1,000 participants that are receiving standard of care Truvada, maybe 4% will become infected, 40 infections in those 2,000 people. Cabotegravir, we hope, is a little bit better. If it's 25% better, it would reduce those 40 infections to 30. Now, to prove that it's reducing by 25% would require a trial of more than 10,000 participants. So we don't have to prove that it reduces 40 to 30. We just have to show that if it's 30, it's better than meaningfully worse than 40. So if we say we'll allow a margin of 1.5, that would be saying 1.5-fold 40 is 60. We want to do a trial where we hope Cabotegravir is reducing it from 40 to 30. We want to rule out that it's increasing it from 40 to 60. 30 versus 60 is a 2-fold difference. That takes 88 events. We have to follow enough people, about 2,500 people, till 88 HIV infections occur. The problem with that design is that study would rule out a 20 infection increase. But are you telling me it's okay to have 20 additional infections? If Truvada can keep it at 40, I don't want to have more than 10 excess. I don't want to have more than 5 excess, because those excess infections are critically important. Well, if we want to, in fact, design a trial where it's 30 against 45, not 30 against 60, that's only a 1/4 difference. That's going to take 256 events, 3 times the number of events, 7,500 people. And there is the tension. When you're designing these trials, people want to do a trial with 2,500. That fits within our budget. Plus, it's more likely you're going to rule out 50% increase rather than a 12.5% increase. And yet, if you do make those trials too small, you're going to, and the margin's too large, there is going to be a serious risk of replacing effective therapies with less effective therapies. So let's suppose we're now doing this NI trial. The NI trial, it really has 2 goals when we're now looking at Truvada against Cabotegravir. One is a goal that's directly assessed. I want to know directly how cabotegravir, the experimental, does against Truvada, the standard. And I get great evidence about that. Suppose when the trial is done, we have 40 infections against 40 infections. That's bad news and good news. Bad news is it didn't improve, even though it was an injectable with better adherence. Good news is it was the same, and that allows us to potentially replace Truvada. But if you do the trial and it's 40 against 40, you're going to say, it's equally effective. You're going to say cabotegravir is equally effective to Truvada. And then somebody critical like me comes along and says, if it's 40 against 40, maybe it's equally ineffective. You had no placebo. So in essence, even though I care a lot about how cabotegravir compares to Truvada, I still really care about whether or not it's better than nothing. But I don't have a placebo. So the assessment of cabotegravir against nothing comes indirectly. I have a direct comparison of cabotegravir against Truvada, and I have indirect assessments because I have historical data that tells me how Truvada does against placebo. But what it means then is an NI trial, for its interpretability, depends heavily on the strength of evidence of the effect of the active comparator. The active comparator has to be highly effective, or that's precisely estimated. So we have to know that Truvada is very effective with precise estimates of the effect. But the other critical issue is those historical trials that are telling me the effect of Truvada have to be relevant to the setting of my cabotegravir trial. And that's called the constancy assumption. And that assumption, which is inherent in NI trials and unprovable, is the major challenge to being able to do rigorous NI trials. Well, you would say, well, come on, Fleming. Those historical trials telling me Truvada's effect, surely they will apply to my cabotegravir trial. Well, there are at least 4 reasons why the effect of Truvada from the historical trials may not represent the effect of Truvada in my cabotegravir non-inferiority trial. The first 2 are probably best illustrated by the setting of antibiotics, where unfortunately we study most antibiotics with non-inferiority trials. So in an antibiotic setting where we said, for example, we're comparing piperacillin tazobactam against doropenem. Piperacillin tazobactam was originally studied in people without piperacillin resistance. My interest in it now is the development. Because of the development of resistance, I want doropenem. But if the doropenem trial against piperacillin tazobactam is now done in patients with emerging resistance, the effect of piperacillin tazobactam in those historical trials won't apply to the NI trial. Second point, supportive care can change, and supportive care can attenuate the effect of the active comparator. So you have a patient that shows up at the emergency room with pneumonia, community-acquired pneumonia. Probably going to give them an immediate antibiotic while I'm waiting to then get that patient into a randomized trial that's going to compare doropenem against piperacillin tazobactam. Well, if I do that, how does that affect the actual efficacy of piperacillin tazobactam and hence the integrity of the constancy assumption? This isn't hypothetical. I was on the FDA advisory committee that basically looked at the data for doropenem against piperacillin tazobactam, and in this trial, 80% of these patients had received amikacin pseudomonal treatment, antibiotic, and an adjunctive methicillin-resistant Staph aureus antibiotic. So FDA said, wait a minute, what is the effect of piperacillin tazobactam in the context of those background antibiotics? And if it doesn't add anything, then doropenem would be equal to it, even if it doesn't have any efficacy. And by the way, this isn't purely hypothetical. In the setting of community-acquired pneumonia, where ceftriaxone was the established effective antibiotic, daptomycin, the experimental, was compared to it. And in that trial, 3/4 of those patients did not receive prior antibiotics. And what's interesting is we see that ceftriaxone, only 1 patient in 8 failed to have clinical cure. Twice as many failed to have clinical cure on daptomycin, which maybe is close to the placebo rate. So we saw the inferiority of daptomycin to ceftriaxone when you didn't give a prior antibiotic. When you did give a prior antibiotic, 25% of the patients, there was no difference. That camouflage, that covered the difference, the ineffectiveness of daptomycin. And by the way, when we used to do these NI trials, because people liked big NI margins to do small trials, we used to have 15 to 20% margins. In the totality of this trial, even though 3/4 were weighted toward sensitivity and no prior antibiotic, you would have, in fact, ruled out the NI margin for an ineffective antibiotic. Another issue that can lead to the violation of the Constancy assumption is lack of adherence. So maybe just a comment as an aside. For any of you that are basketball fans from the NCAA annual basketball tournament, what you know, sadly Washington hasn't gotten there for 6 or 7 years, is that only 68 teams get into that tournament out of hundreds of colleges throughout the country. A skilled basketball coach knows that to get the invitation to be in that tournament, they need to be perceived to be a strong team. They have to have what's called the RPI. That rating has to be good. How do you get a good RPI? You beat other teams that are perceived to be really good. Well, non-inferiority is a little bit like this, like a skilled basketball coach. If you have a new experimental therapy you're going to study in an NI trial, you want to find an active comparator that's perceived to be really good, because if you're similar, you want to be viewed as similar good, but not so good that you can't do well against it. So how do we do that? We find an effective agent like Truvada that was studied in superiority trials by the sponsor for Truvada that made sense, that made sure that we had sensitive patients where we weren't diluting with supportive care and where we had high levels of adherence for Truvada. And we got a great estimate for Truvada's effect. Now in the NI trial, when we're comparing Cabotegravir to Truvada, this is now being done by the sponsor for Cabotegravir. So they want people to know that Truvada is effective, but it's okay if we're now studying it with somewhat resistant patients or where the adherence to Truvada isn't so great. Does adherence make a difference? Yes, it does. We've already seen this with Truvada. Adherence does matter. Suppose we were going to do our trial of Cabotegravir against Truvada in this FemPrep setting. And while in truth this was a trial of Truvada against placebo, just for a moment, suppose this had been Truvada against Cabotegravir, and you get equal results, and you're excited. Cabotegravir is good because it's essentially equal to Truvada. And Fleming says, well, is that equal ineffective or equal effective? And you say equal effective. And I say, how do you know that? Well, look, here's another heterosexual woman trial in heterosexual women. And in this trial, where we did look at Truvada against placebo, we saw that Truvada reduced transmission by 2/3. Hence, it must be reducing it by 2/3 here as well. Well, we know in truth it isn't. And we would have had a flawed argument using that approach. And the reason it was flawed was the constancy assumption didn't hold. The effect of Truvada in this setting wasn't the same as the effect of Truvada in the CDC Botswana setting. Another issue is the endpoints can matter. In an oncology trial for survival, if we're looking at docetaxel as the control arm in non-small cell lung cancer, maybe it affects 2-year survival, and hence it was established to be effective, but it doesn't really affect 1-year survival. And now a sponsor that wants to look at Alimta against docetaxel wants to do a short-term trial. We're in a hurry, want to get quick answers. So we'll look at a 1-year endpoint and show we're the same at 1 year. Well, but docetaxel isn't effective at a year. So the endpoint can change and can also impact the validity of the Constancy assumption. I do want to just quickly touch on this example, and that was one of the, fortunately, there are very few NI trials in oncology. Rick Pazder, after this experience, Rick Pazder, a leader at FDA, who's been a leader for many, many years, recognized the fragileness to the integrity of NI trials. And in fact, he asked me to publish an article with him about 10, 15 years ago on the inferiority of non-inferiority. I would like to join that. So in essence, in this setting, docetaxel, Taxotere was standard of care. Alimta was being studied in non-inferiority, where the idea was if it was the same in survival, that would be good because it reduced hospitalization for febrile neutropenia, although it didn't reduce overall hospitalization. So in essence, the trial design, the trial at the end of the day showed exactly equal relative risks on survival with an upper limit of 1.2 for them. Unfortunately, the trial, when it was designed by by Lilly, the company, had set up an NI margin of 1.1. They were hoping they'd be 0.8 ruling out equality for superiority, but worse, they'd be 0.9 ruling out 1.1. They got 1.0 ruling out 1.2. So they said, well, we believe in this. Let's see if we can justify a 1.2 margin. If in fact we can prove that docetaxel is highly effective, it's good enough just to be 20% worse. So they went to the historical data. There were 2 superiority trials in the literature looking at docetaxel against best supportive care, one with 400 patients, one with 200 patients. The 400 patient trial didn't show any effect of docetaxel against the active comparator, which was vinorelbine ifosfamide. So in a post hoc argument, the sponsor, Lilly, said, well, that's probably because vinorelbine and ifosfamide itself is so effective that an effective docetaxel doesn't show up as being better. Post hoc argument. There were another trial, TAX 317, that had 200 patients, 100 that looked at high dose against best supportive care. It too didn't show any effect of docetaxel, but there were 100 patients of low dose against best supportive care that had what they hoped, a hazard ratio of 0.56, almost a doubling in survival. So they said, well, these studies, this doesn't apply because it has an effective active comparator. This is the wrong dose, although wait a minute, it's a higher dose. How often is a higher dose completely ineffective and a lower dose highly effective? Can happen. It justifies the use of the lower dose, but you got to be worried about random high bias when you're doing a post hoc assessment. And in essence, therein lies one of the inherent problems with non-inferiority. You cannot do what they did, which is to go back and change the NI margin post hoc. But even if they had pre-specified the NI margin, it was already after these data exist. If you believe that you can survey your data and choose the results you like and view that that doesn't have random high bias, please come to Biostat 524. One of our most important lectures, lecture 5, talks about random high bias. So we need a process for objective assessments of the effect of the literature data to get an unbiased estimate of the effect of the active comparator. So I want to spend the last 20 minutes or so walking you through an example of how we actually properly develop an NI margin. I could use any setting. I'll use the setting of the antiplatelet 2B3A inhibitor, where in percutaneous coronary settings, it's been shown to be highly effective in reductions of MI, and the composite endpoint in particular, death, MI, urgent revascularization. But it does have an increase in major bleed. So bivalirudin was being studied as a non-inferiority comparator. So here was the study, REPLACE-2, that directly compared the experimental bivalirudin against the standard of care 2B3A. Well, we know we need a margin, and that margin needs to be evidence-based. And so what's critical is we need to know the effect of the 2B3A inhibitor. And we know that to do a valid NI trial, the 2B3A inhibitor has to be highly effective, where that's precisely estimated, and where those estimates are relevant to the setting of the REPLACE-2 trial that's going to be conducted to look specifically head-to-head bivalirudin against the 2B3 inhibitor. Well, there are lots of interventions that we use as standard of care that don't have superiority trials that are well-designed, well-conducted with precise estimates of effect. Fortunately, that it is the case that we do in the setting of 2B3A. We have the EPISTENT and ESPRIT trials that together allowed us to look at whether 2B3A beat nothing in the background of heparin with about 240 endpoints, so considerable precision, where it almost halved the rate of death, MI, urgent revascularization. So we've satisfied the first 2 criteria for an NI trial. The active comparator is highly effective, where that's precisely estimated. So how are we going to use this data? I'm going to pictorially show essentially the reasoning that we're going to use in non-inferiority. In non-inferiority, bivalirudin, the anchor for its efficacy is entirely the 2B3A. So the 2B3A is the anchor. Everything is compared against in a hazard ratio of death, MI, urgent revascularization against the 2B3A. If bivalirudin is the same in terms of the endpoint of death, MI, urgent revascularization, it lives right around here, bivalirudin, right where the 2B3A is. We hope it's actually a little bit better, a little bit to the left. Surely hope it's not to the right. If in fact it is the same as 2B3A, if placebo is also the same as 2B3A, then you've just shown that you're equal to placebo. That's not good enough. So we have to hope that placebo is over here on the right. Where does placebo reside against the active comparator 2B3A? That's our challenge. Well, we can get at that with EPISTENT and ESPRIT. As EPISTENT and ESPRIT say, that the 2B3A has about half the rate of death, MI, urgent revascularization compared to nothing. So if 2B3A is half nothing, then by inverting it, nothing, placebo is twice 2B3A. So I simply invert this hazard ratio. So if 2B3A to nothing is 0.55, nothing to 2B3A is 1.82. The lower limit, 1 over 0.71 is 1.40, 1 over 0.43 is 2.32. So by inverting, I now know that in EPISTENT and ESPRIT, the placebo against 2B3A has about an 82% higher rate of death, MI, urgent revascularization, with a lower limit of at least 40% higher. So now I have the ability to place where placebo is in this figure. And it is off to the right, as I hoped. Placebo lives over here at 82% higher rate of death, MI, urgent revascularization compared to the 2B3A. Two problems. One is that's not the definitive truth. That's what it's estimated to be. So I have to take into account that variability. But even more importantly, I have to take into account that this is where the 2B3A resides. This is where placebo resides against 2B3A in EPISTENT and ESPRIT. I want to know where it is in replace 2. I want to know the Constancy assumption holds, and the concept may not hold for all these reasons. Yes, it will, Fleming. You worry about minutia. Well, do I worry about minutia? Are these issues, in fact, real? Yes, they are. It may well be that the 2B3A was studied in EPISTENT and ESPRIT in patients more sensitive, where background therapy was better. Here's one of the problems. When EPISTENT and ESPRIT were done, they were done based on state-of-the-art medical understanding about the best way to use that platelet inhibitor according to background therapy. As time evolved and medicine advanced, we may well have learned about better ways of giving background therapy beyond the antiplatelet. And so we may have, for good reason, changed how supportive care is delivered when you give 2B3A, when you're now wanting to do replace 2. The unfavorable forces of non-inferiority are saying, oh, no, if you're going to study the new agent, the bivalirudin against 2B3A in replace 2, you got to deliver everything the way you did back in those days when you did EPISTENT and ESPRIT. That's unfortunate. So, in fact, we won't be doing a perfect match. And so we don't know that this estimate of where placebo is against 2B3A in EPISTENT and ESPRIT applies to 2B3A. There is no answer to how to adjust it. There's no statistician you can call that can give you the formula that makes the adjustment. And so what we do is a convention. Doesn't necessarily make the right answer, but we say that we're going to take the lower limit of the 95% confidence interval for where placebo resides against 2B3A and EPISTENT and ESPRIT, and that's where we're going to consider that it resides in the non-inferiority trial replace 2. And essentially then, if bivalirudin against 2B3A has a confidence interval that rules out this lower limit, then we will say it's effective. And that's called, if you read the literature, that's the 95-95. You're taking the lower limit of this 95% confidence interval and the upper limit of the 95% confidence interval from the NI trial for bivalirudin against the 2B3A, and those two cannot overlap. That's convention. Now you might say, gee, that's conservative, Fleming, because you're taking the lower limit of what the estimate is for where placebo is in EPISTENT and ESPRIT, and you're saying that's where it is in replace 2. And I say, may not be conservative, because the circumstances for how we are actually delivering the 2B3A in replace 2 and the nature of supportive care and how we choose endpoints and how we get adherence, it may be less effective even than this lower limit. So in essence, where we are is we have EPISTENT and ESPRIT that tells us about the 2B3A, the active control of the 2B3A, and specifically tells us that placebo has an 82% higher rate of death, MI, urgent revascularization against the 2B3A, with enough precision that the lower limit is 1.4. But because the population adherence, supportive care, and endpoints used in REPLACE-2 may differ and will differ to some extent from EPISTENT and ESPRIT, we're using the lower limit. And so as I say, if in fact, when you now do your REPLACE-2 trial, if your estimate of bivalirudin is somewhere around here with an upper limit that rules out 1.4, we can now conclude that you're better than placebo, that bivalirudin is better than placebo. Do you market it based on that? Do you use it in the clinic based on that? Well, it wasn't ethical to do a randomization against placebo once you'd already now advanced with 2B3As that have the rate of MIs. Why is it therefore adequate to show you're beating placebo when placebo wasn't an admissible control? And so many of us believe that it's not good enough for bivalirudin to be shown to rule out where placebo resides. We have to rule out that we're losing any more than an important fraction of the effect of the active comparator. So if we say that fraction is half, let's say you want to rule out that you're losing half of the effect of the active comparator, the square root of 1.4 is 1.19. So half of the effect of 1.4 is 1.19. You say, wait a minute, Fleming, half of a 40% increase is a 20% increase. Well, this is all on a log scale because in time to event analyses, we're not estimating the hazard ratio, we're estimating the log of the hazard ratio. So half the effect is the square root. So in essence then, it means that if bivalirudin is estimated to be sufficiently favorable against 2B3A such that the upper limit rules out 1.19, we can then conclude that not only is bivalirudin effective, you're preserving at least half of the effect of the 2B3A control. We're almost done, but not fully done, because there still is, this is the argument in the literature for what's called M1, justifying the MI margin from an M1, that you're preserving at least half the effect of the active comparator. There also has to be an M2, a clinical common sense. So you're hearing this from a statistician. The most important goal in clinical research is not statistical significance. Lest you think I'm trying to put statisticians out of work. Statistics matters, but the most important goal is clinical relevance. What I want is statistically persuasive evidence of clinically relevant effects. I want to know that if I'm going to declare that I can replace 2B3A with bivalirudin, I got to know that I'm ruling out excesses that are in fact clinically admissible, acceptable in the context of, in this case, lower bleeds. So if you're saying it can be up to 19% higher rate of MIs, that means you're saying a 5% increase is okay. Patient would say 10% is okay. In fact, I'd like to have NI margins defined by patients, not by researchers. Does a patient truly say, I'm fine with 10% more MIs, I'm fine with 15%. It's just that it can't be more than 19% more MIs. Okay. Well, do I allow more MIs? I do allow more MIs. I do allow loss of efficacy if there are offsetting reasons. I'm going to allow some additional risk of HIV transmission than with Truvada if I'm using Cabotegravir, if I can spare the use of Truvada to a treatment setting. Because if I become infected, at least I want an effective therapy for treatment. In this particular setting, what is the trade-off for bivalirudin against 2B3A? Well, one obvious benefit of bivalirudin is I'm getting rid of 2 major bleeds per 100 patients. That matters. I'm getting rid of 2 major bleeds per 100 patients. But if I allow a 19% increase in death, MI, urgent revascularization, that 19% or 1/5 of 7% is about 1.5%. So clinically, to defend this NI margin of 1.19, we have to be able to say, I'm getting 2 fewer major bleeds, I'll allow up to 1.5 additional MIs. Major bleeds matter, but MIs are irreversibility and mortality. So I surely could not justify a margin of 1.4, which would basically be saying I'd be allowing 3 excess MIs to prevent 2 major bleeds. So this seems to me to be the biggest margin that you could clinically justify as a patient, that you're going to allow up to 1.5 additional MIs in exchange for 2 fewer major bleeds. So what did the data actually show? The trial, again, comparing bivalirudin to an effective 2B3A that reduces MI rates by 50%, says, okay, if bivalirudin is really 10% better, 0.9, and we rule out that it's 19% worse, 1.19, 0.9 divided by 1.2 is 0.75. That takes about 400 to 500 events to be highly powered. It's going to take a trial of 400 to 500 events. What do you have? A 7% event rate. It means you need about 15 patients per event. So you need about 6,000 to 7,000 patients. That's what it was. It was a 6,000 person. That's why the trial was 6,000 people. It's a 6,000 person trial with, in fact, about 450 events. And in fact, if bivalirudin was slightly better at 0.85, you would have ruled out 1.0 and you would have had superiority on death, MI, urgent revascularization. It wasn't. If it were essentially neutral at 1.0, which was the idea, it should be at least neutral, your upper limit would have ruled out 1.19. It wasn't. It was a little bit worse. It was 1.09, where the upper limit therefore was 1.32. So with the actual data, we now have our NI margin. We now know where bivalirudin resides. We plug it in. It doesn't reside over here. It resides over here at 1.09 with an upper limit of 1.32. Okay, those are the data. Do these data allow you to conclude that bivalirudin, the experimental therapy, beats placebo? Does it beat placebo? Is it effective? Yes. Yes, it is, because you're ruling out 1.4. It is better than nothing, but it doesn't preserve half the effect, 1.32, 840. It preserves only about 20% of the effect. So it doesn't meet what I would consider a standard rigor for establishing that if I'm going to replace a very effective active comparator, I want to know that it's preserving more than 20% of its effect. So in conclusion then, when we're setting up NI trials, the art of this is the development of the NI margin. We all want positive results. Talk about that in lecture 5 in Biostat. We have legitimate reasons for wanting positive results. We want big margins as a result that allow us to have a good chance of showing the experimental therapy is adequately effective in small sample sizes. It's relevant to want that. And yet, if I'm going to compare bivalirudin against a standard therapy, 2B3A, which is, in fact, one for which there is reliable evidence of efficacy, I need to have a rigorous NI margin. And that rigorous NI margin needs to satisfy 2 criteria. The first is you've got to address the inherent bias or unreliability. So to illustrate this point of the fact that, yes, we do in medicine adjust for the bias or inherent unreliability. Suppose that when you were studying bivalirudin, instead of doing an NI trial of bivalirudin against 2B3A, suppose you did an historically controlled superiority trial treating everybody over here with bivalirudin and going back to the pre-2B3A era and finding historical control patients that weren't getting antiplatelet therapy. So you're going to do a superiority historical control trial of today's patients getting bivalirudin against historical patients getting no antiplatelet therapy. I hope any one of you would say, at the end of the day, that comparison is fragile, potentially flawed, because today's patients aren't like the historical patients. You have confounders. And if you do an historically controlled trial, we all know that you've got to take a major adjustment for the uncertainty of lack of randomization. You say, Fleming, why are you talking to me about this in non-inferiority? The 2B3A historical trials, EPISTENT and ESPRIT, were randomized. And replace 2 that's comparing bivalirudin to 2B3A is randomized. So we don't have to worry about these confounders for uncontrolled covariates. but we have confounders that are effect modifiers that aren't controlled. The EPISTENT and ESPRIT trials were done in different settings than the REPLACE-2 was done, and those settings can create different effects for the active comparator. And there is no way to know whether those effects are different by an unacceptably large amount. So you must, in fact, take an adjustment for the uncertainty as to whether the effect of 2B3A in REPLACE-2 is the same as what it was in EPISTENT and ESPRIT. Second point is, yes, you do need to preserve. It's not enough to be placebo. To illustrate this point, John Powers and I wrote an article in CID looking at the effect of antibiotics, which is sulfonamide derivatives and penicillin, in the 1940s and 1950s when antibiotics were first identified and used for pneumonia. And in that setting, we were looking at the effect of antibiotics against no specific therapy in community-acquired pneumonia on mortality, specifically 21-day mortality. And while we looked globally to show you the results specifically in non-bacteremic, I hate to call this elderly that my age, patients over the age of 50, we found antibiotics were extremely positively effective. By the way, they were in all the other groups as well. There was a 2/3 reduction in mortality. Now, suppose in modern day, you want to take a new experimental therapy, non-antibiotic, that you want to study in a setting of patients who would be candidates for antibiotics. And you're going to compare to no specific therapy, and you show you have a 25% relative reduction that is statistically significant. Is that evidence of, let's say it's an antipyretic. If that antipyretic therapy is statistically significantly reducing mortality in a cohort of patients that are candidates for antibiotics, is that sufficient evidence to approve and use that antipyretic therapy instead of antibiotics? And if you say yes, please don't be making decisions about how to treat me when I have pneumonia. No, not now. The field has changed. Now when you know you can make a major anti-death or reduced mortality effect, it's not good enough to be placebo. I wish all presidential declarations were this wise. In 1995, Clinton and Gore made the declaration, a policy statement that said it's essential for public health protection that a new therapy be as effective as alternatives that are already approved for marketing when those, not when it's an analgesic, anti-asthmatic, antipsychotic, but when it's irreversible morbidity, mortality, or where it's an infectious process. Then it's not good enough to beat a placebo. If you're going to replace effective therapy that is reducing morbidity and mortality, it's got to be with something that preserves the effect of the active comparator. So in essence, then the margin needs to be chosen with statistical precision, but with clinical judgment, that you are truly, from the patient's perspective, not giving back efficacy. So the margins have to be chosen in a suitably conservative way. One of my PhD students here at UW and some colleagues from FDA and I wrote an article on essential considerations in the design and conduct of NI trials. And we argued that non-inferiority trials with non-rigorous margins can really lead to the erosion of quality of healthcare. So if, in fact, you wanted to do the 2,500 person trial when you're comparing Truvada against Cabotegravir, and that margin you're going to use is 1.5, I'll tell you right now, you win with an estimate of 1.17. So even if you estimate that you have 15% higher rate of HIV infection, you're going to rule out that 50% increase. So okay, then we'll approve Cabotegravir with an estimated higher transmission rate. So now the next generation intervention comes along. What are they going to compare to Truvada? No. They're going to compare to Cabotegravir and ask for a 1.5 margin again. We call this biocreep. And it's happened in medicine where you compare to a comparison, and you're allowing flexibilities in those margins, and pretty soon the really important advances that you've made can be eroded. So when you consider yourself an expert in a discipline and you believe you know it well, you tend to be an advocate for that method. Well, I've spent a lot of time on non-inferiority. I think I know it well, and I'm an advocate against it. Okay, i.e., any time that you can do a trial that is based on a superiority design or alternative to non-inferiority, I urge that you do. There are settings that we can't, that you truly do have irreversible morbidity and mortality for the active comparator, and you're not expecting to be better, but you're going to make a major advance. Not a Me Too drug, not a Me Too antibiotic, but where you really think you can reduce cost, inconvenience, toxicities in ways that patients would allow lesser efficacy. Those are the settings for non-inferiority. I'm going to make a 30-second pitch, since I have all of you as a captive audience. We went very quickly through non-inferiority. There's a lot more that I would like to say. And every spring quarter, we have the design of medical studies, Biostat 524, where we talk about addressing scientifically challenging issues in design. You need to randomize. You need to have blinded assessments. How do you do non-inferiority trials in a valid way? We talk about conduct issues, getting rid of missing data, talking about the importance of data monitoring committees and independent oversight to protect the integrity of trials, and the challenges that we have to preserve nowadays the independence of data monitoring committees. We talk about analyses and reporting, and I always say lecture 5, you come to one lecture, please come to that one. This is an important one on non-inferiority, but the one on exploring your data, we all want positive results. If you think you can explore your data and look at multiple endpoints, multiple analyses over time, multiple covariate adjustments, and not pay a price for being significantly misled because of random high bias, please come to this class. So my final pitch is, I would love to see you, and if you can't make it, let your colleagues, your students know. I'd love to have them all involved. We have great contributions from medicine in this class over the years, and I appreciate that. Thanks.
Thank you so much, Dr. Fleming. We have time for questions. Unfortunately, we don't have the mic that we usually carry around to you. So if you have a question, we're just going to repeat it for our remote sites.
Fabulous way to start off Grand Rapids. Thank you. In your reading of this literature, I mean, has anyone done a structured review of non-inferiority trials? And if so, what's your gestalt about the proportion of them that would sort of meet the standards that you laid out?
That's a great question. Thank you. So the question is, have there been systematic reviews of the experience with NI trials? There is, on a good news sense, an increasing level of attention to the rigors of these trials, and there have been major advances. The fields differ very much in how frequently they use these designs. Cardiology, very infrequently. Oncology, very infrequently. Anti-infectives, almost all the time. And the good news is anti-infectives has greatly improved the rigors in NI trial over the last 20 years. It used to be that if you had a new antibiotic, basically the easiest way to show it's effective is not to go into pneumonia, it's to look at acute otitis media or acute bacterial sinusitis or acute exacerbation of chronic bronchitis. The problem with those NI trials, where you have an 85% success rate on the control arm and they use margins of 10 to 15%, is that a placebo would assuredly win. If you in fact have acute otitis media and you go to a caregiver, a pediatrician, what do you want them to do? You want them to do something. What are they going to do? Often they give you an antibiotic. What happens after you get the antibiotic? The child's ear infection goes away. Post hoc ergo propter hoc. It must have been because of the antibiotic, right? Finally, we've now in recent times done superiority trials in these settings, and what happens on placebo? The infections go away almost the same time. So we were approving all kinds of new antibiotics in an easy way. And sponsors loved it because it was very easy to get a new antibiotic. You knew it was going to, if it's a placebo, it's going to win on those kinds of criteria. So we do know that there are massive experiences. We have been, and they're mostly coming out of where we're using these designs, unfortunately, too often, which is in the anti-infective world. The other way that we're using them in the anti-infective world today is correctly we're saying we have effective antibiotics. Antibiotics do work. I believe they're not needed for acute otitis media, but they are needed for pneumonia. But we're developing resistance. So the way we now do antibiotic trials for the development of a wider arsenal of antibiotics to address the fact that our existing antibiotics have emerging resistance is we'll take a susceptible patient and we'll randomize them to a new antibiotic against the existing antibiotic that's known to be effective, where this isn't like Cabotegravir, where you're going to at least preserve the patient's beneficial access to Truvada once they're infected. This is, they're totally effectively treated with an existing antibiotic. You're going to give them something that's new, that's at best the same, maybe worse, where the endpoint's death. And our informed consents do not point out that truth. And so effectively what we're doing is we're doing non-inferiority trials to show that we're not worse with the new antibiotic in a setting where the existing antibiotic works when it's susceptible, because we're trying to get that new antibiotic to be out there, to be available when resistance develops here, so that I would have it for multi-resistant patients. No, that should be a superiority trial in patients with resistance. So the question is a great one. We have massive experience in the NI-infective areas. We're doing better than we were, but still think very carefully about the ethics of what we're doing today and whether we should be doing superiority trials rather than NI trials in pneumonia patients in susceptibles.
James Floyd. Thanks for that excellent talk. The FDA has improved their regulatory standards for conduct and non-inferiority trials substantially in the last 10 to 15 years, I think in large part from your efforts. But there have been concerns that this standard is loosening. For example, we've seen expansion of expedited approval pathways and the usage by sponsors. Do you have a sense of the current standard where there are clear guidelines on endpoints and trial designs are going to continue?
Yes.
Or they're being eroded right now?
So thanks, James, and thanks for the efforts that you've made in the past decade and more in trying to address these standards for non-inferiority trials. My sense is if we ever step back and say we have arrived, we are at great risk, because there are valid tensions that exist in clinical research. There are valid reasons to want to be able to do things in a streamlined way, to be able to have smaller trials, to be able to have shorter term trials, to be able to get therapies to patients in need in a more timely way. And those pressures basically are based on the argument that, look, patients just want a choice. And my argument is that's missing the essence of what patients don't just want a choice, they want an informed choice. So it's our responsibility to do research in a way that not only allows for more timely access to potentially effective interventions, but to make sure we have a proper evidence-based justification for that. And the problem is, the context for this is, there's an inherent widespread bias toward positive results. Sponsors want positive results because that allows them to market products and increase profit line. And they have a big effect on Congress pushing for that. But NIH wants positive results, and we did that landmark trial showing prevention of transmission of HIV by treating the infected person. Medical officers at FDA said, at NIH said, yes, this is really important to public health. It's really important to us too in being able to leverage and get more funds from Congress for NIH research. Journals like positive results, and so they're more likely to publish positive results. So we in academia, we want to get promoted, we want to have notoriety, we want positive results too, and caregivers want more options. All of those are valid, but they are all creating a pressure and a tension against the integrity of research, which ultimately is critical for the interest of improving healthcare for treatment and prevention of diseases in an evidence-based manner. So what you're saying is very true. We have moved the dial, not to where some of us want it to be, but it's gotten better in terms of the rigors of science in non-infectives, particularly with NI trials. But there are these constant pressures, political and scientific and business related, that are pushing it back on a regular basis. So the reason that I'm so delighted, I always say to all of you, you're the future. Don't thank me for this lecture. I'm thanking you for being here for your sake and the students, because the job that has to be done still is significant lying before us to make sure that we are recognizing vulnerabilities with methods that are strongly advocated because it gives us a quicker answer in a smaller sample size, more likely to be positive, but at the expense of reliability for patients and being able to have an informed judgment for patients.
All right, I think we're out of time. Thank you so much again for that excellent talk. If there are other questions, feel free to come down front. Otherwise, have a great day.